Welcome, everyone.
Welcome. I am Sebastiano. I am an Android GD, and I work at JetBrains.
I'm Neil. I'm an Android software engineer, not a GDE, and I work at Toyota Connected Europe. So yeah, and
It's
also
your birthday. Happy birthday, Neil.
yeah.
Happy birthday.
So yeah, there's nothing I'd rather do than give a presentation on my actual birthday. So, woo.
Best present you can make to yourself.
And I was not aware that that previous slide was going to be in the slide deck. So yeah, so we're talking about everything CI related, static analysis, testing, etc. So static analysis, we're going to start off with why it is important. So it's going to help you with your code quality. It's important that you have some sort of consistency in your project when it comes to just like a baseline with quality. We can define quality as the way you're writing your code is like consistent across your team, the amount of maybe testing you have, certain coding standards and practices that you adhere to. And you want that to be unified not just across the people within your team, within your project, but as a community as a whole. So there are certain guidelines that people will follow that you should stick to because it means everyone is on the same page, everyone is there to help each other out, and it makes our lives easier. You could also look at the example of changing job. You know, if you go to somewhere and everyone is adhered to the best practices, then your time to onboard is faster. You want to follow this rule of never fix the same bug twice. So there's a great practice that if you have a bug, write a test first that shows the bug failing, and then write the code that fixes that verifies that your test is verifying. So that way you will never have to deal with the same bug twice. That is just a simple practice to help your team. TDD, as I hope a lot of people here will know. And also just having static analysis means you have to fix less bugs in the first place. It's just kind of catching a lot of things that you might miss. Your focus might not be on the little nitty-gritty details where it comes to styling or just certain things that you come across. So you want to just kind of have that baseline brought up a little bit. Yeah, so it's a safety net to catch these easy mistakes. But how do you achieve this baseline of quality? So testing, static analysis, and ACI. We'll go into the details of static analysis and CI soon, but just quickly on testing. So do test. If you don't have any tests and you haven't written a test, feel free to stand up right now, go grab a table, write a test, and come back. So you should all be writing tests.
You're not allowed here if you don't have tests.
That is unit and integration tests. So obviously, there's a lot of push for unit testing, just testing little parts of logic in your program work. But also, you might want to consider having longer range tests that maybe verify a user flow. It's a really great way as a developer to kind of help justify your code's functionality in a business sense. So if you have some sort of proof that says a user journey from A to B in your app can be verified, that's not only a really good thing to have in terms of the quality of your code base, but it's something that people maybe in different departments will be able to understand as well. But testing is a crazy big topic, and there's a lot to cover from how to write good tests, like a million different things. And there are lots of talks on testing either here or in other conferences or a million articles that you should go read. So we're not going to cover testing itself, but just in general, what we're going to do is provide you how to add testing and static analysis into your development process in the best way, so you can kind of utilize the benefit that these things offer. So static analysis, tools that analyze your stored code statically. That is at rest, not at runtime. And it's basically checking for common bugs and insights or oversights. It may involve analyzing the bytecode. So that will happen, obviously, after you compile. And it can also check for code style violations. So these are kind of the two main categories of most static analysis tools: checking for bugs and oversights, and then styling in general for your code base. So we all come from Java. Kotlin is now 2 years supported as a first-class language, yeah. I think.
Next month.
So we all come from a Java background in Android. Some people are unfortunately still stuck there. A lot of more commonly, people may still be in the migration process of going from Java to Kotlin. So you're kind of maintaining two languages in the same code base. Java in general has a lot of static analysis tools. The list is huge. They are very mature. Most of these are free or open source. Some are commercial. This would be for more specified cases, maybe in relation to security and stuff. So that would be more on a case-by-case basis that you might want to consider that. But in general, and mostly for Android in like the general cases, the free tools, the open source tools are the ones that you can use to kind of get this real big benefit of using static analysis. And if you have heard of static analysis in CI, you have probably come across find bugs, PMD, and check style. Just a note that find bugs is no longer being developed on, and it's kind of moved over to spot bugs. So if you want to keep up to date and be with best practices, maybe move over to spot bugs now. As you can tell by the name, they're very similar.
One is the fork of the other.
Yeah. And yeah, so these are the main toolings. The top two, find bugs and PMD, or spot bugs, they will come under the kind of common bugs violations category, and check style is for more the code stylings category of static analysis. There are plenty of others, error prone, infer, Android lint. If you have experience with iOS or anything, there are also tools that maybe cross over there as well. The list goes on and on, but Java is incredibly supported here. And don't forget your IDE. So Android Studio has a lot of inspections. One note for this, so a lot of the inspections will kind of tell you things that might be picked up by PMD, check style, spot bugs. But it's important to realize that you want your single source of truth to be your CI and your static analysis tools, because as a team, you don't necessarily have control over people's IDE inspections, and you can't rely on them to be enforced, because sometimes it's just a suggestion or a warning that people don't necessarily need to adhere to. So, and then obviously once you push code from your laptop or whatever into the version control system, then those inspections are no longer part of that process. So rely on your static analysis tools in your CI and not on your IDE inspections, but still use those inspections. They're in editor and on demand, so quite often as you're coding, some warnings will come up and say like, hey, you should do this, or this is bad practice. But there are some checks that you can run in your IDE that are just a little bit more intensive, that take more time. But it's useful sometimes to use them just before you push if you're not wanting to wait anything. Want to make sure your code is valid before you let a machine fail the build. And also this building code formatter. So a really good recommendation here is to have your code styles in your version control. So whenever someone checks out the project, they have to adhere to the same formatting as everyone else. The worst thing would be to spend time reviewing PR after PR of just minor styling changes that kind of take away from the meaning of whatever code is being pushed. So you just want that to kind of set it, forget it, and use Control-Command-L, which is the auto format. Get used to using that.
Command-Alt-L on Mac.
Command-Alt-L, that's one.
Yes.
So get used to using that while you're programming to make sure the files you're working on are always formatted. So yeah, that is Java. Java is super mature, has a crazy amount of support, but what about Kotlin? So the good news is Android lint works. So Android lint kind of helps you adhere to best practices and checks out some things that maybe lead to bad longevity of your code and bugs in the future. And we still have IDE inspections, so even though I said not to rely on them as part of your build process, still use them as much as you can, especially while programming Kotlin, to kind of listen to the warnings, listen to the best practices. The inspections, again, are not as many and not as complex as Java. Kotlin is still relatively new, but a lot of the support is getting better and better with time, so the more you get used to using it, the more new things will pop up and the better support will be given. The bad news is that is pretty much everything that from the Java world that we can use in Kotlin. So Android lint is basically the only thing. There are no first-party tools from JetBrains. The IDE inspections are, so they're useful, but there is no tools out there yet that have been created to help us kind of adhere to these standards. And often the formatter is not strict enough. If people here have had experience using like code formatting in Kotlin, quite often you'll notice that there's just slight styling things that you'd want to see that you've seen in Java that just aren't there. So it can be a little annoying, but it's just important to try to use it as much as possible and try to let it keep the consistency that it offers across your code base. The good news is there are a few new tools for Kotlin. So there is KT-lint, there is detect, and there is another tool, SonarCube. So what is KT-lint? KT-lint is an anti-bike shedding Kotlin linter with a built-in formatter. So an anti-what with built-in formatter? In case you haven't heard the term, anti-bike shedding basically means avoiding pointless conversations. So the little tweaks and little things in your code that should be standardized across the team, this will do for you. It falls into the second category that I mentioned previously, like the styling kind of static analysis. So you don't want to have the arguments or have inconsistencies around small styling things like where a bracket goes or if there should be a new line somewhere. So this will offer that for you and just allow you to kind of set it and forget it on those tools. Yeah, and avoiding customization where there shouldn't be. Linter basically means that it verifies code quality for potential errors. And KT-lint only looks at source code. It doesn't look at bytecode or into like the syntax tree or anything like that. It is kind of the equivalent of check style for Kotlin, just not quite as configurable, not quite as mature. It does follow the official style guide, which is great, because again, consistency not just within your team, but across the Android community is something that's very important. And as Android developers, it has specific support for Android styling, which is great, and it's useful. Use it. And you can auto-fix a lot of violations that it offers with -f. So again, just kind of the same way that maybe you use the auto formatter with Alt-Command-L.
Command-Alt-L, yes.
Yeah, the same way you use that is kind of, you can get used to using -f to kind of fix minor violations as well. And it has some configuration that can be done in the editor config file. And then there is detect, which is another tool, which is a static code analyzer. So it is more similar to PMD and find bugs. You'll notice that we're trying to kind of piece together the same free tools we had in Java in Kotlin to try and have some sort of equivalent. This inspects code and the abstract syntax tree, so as after the code is compiled. It does not inspect bytecode, so it's not quite as detailed as some of the other ones from Java. And there is a limited type resolution capability, so if you have some crazy generics in Kotlin, it might not be able to pick up on that and might not be able to offer support if something is wrong or not quite matching up. And it is configurable by a YAML file, so I won't run through all the specifics on these bullet points, but there is a config file. The most important part here is that you can build on the default config. So instead of having to, if you want to customize your configuration, instead of rewriting it from scratch, you can build on the delta of it. So you can say, I want all of that stuff plus this or these changes, which means it's a bit nicer to kind of make small customizations to your project. And it has a plugin for Android Studio as well. And the violations will be shown in your editor, so you can fix them as you go, rather than waiting for a build to fail and come back with some sort of set of results. And finally, there was SonarCube. So SonarCube has great Java support. It supports God knows how many languages. Like, there's a lot. Kotlin is kind of supported. So we can use Android lint and detect. It doesn't support KT-lint, so that's not great, but it's at least a start, and maybe in the future it will. Again, all of these tools and like integrations are still kind of new. It's not nearly as comprehensive as it is for the other languages, but again, there's a lot of maturity from Java compared to Kotlin. So give it time and a lot of things will improve. And obviously, if you have a project that is in the migration stage of going from Java to Kotlin, then having at least one set of results of your code quality can be useful. So this can bring it together in one place. So then you can have at least some area where you can go, okay, this is the one source of truth that we can work from to see where violations are and what improvements we might want to make or where things are going wrong. So yeah, just to recap quickly, there is some good stuff for Kotlin. So there is no excuses not to use it. If you're programming in any language and it has static analysis tools, use them because it will help you in the future. It will save you time. Yeah, Java has been around 24 years compared to Kotlin being around not quite 2. So give it time, it will mature, things will get better. And also, there's a lot of lessons learned from Java in terms of creating this tooling. So we could maybe make the assumption that the tools for Kotlin will progress faster. So we're not going to be waiting 24 years to have the equivalents. So that should be good. And yeah, use all of these tools and listen to your IDE inspections. So we've covered static analysis. We now know like how to keep our code quality consistent. So what is a CI? So CI is continuous integration. It is not a new concept. It's been there since the 90s, popularized by extreme programming. It basically means you're continually integrating all of the changes, catching the issues ASAP. So if you have a bug in your app, you want to find it when you're trying to push it or before you're pushing it into the code base. If you are deploying a release and you find it, a user finds that bug, that is the last point in which you want to find a bug. You want to catch them as soon as possible, fix them, and continuously keep making improvements in your code base. So yeah, you want to leverage the build system, compiler, tests, static analysis all together. That is kind of what the CI is doing. Do you want to continue?
Yeah, sure. So CI is a practice. Basically, when we say I have a CI, what you're really saying is I'm following the continuous integration as a practice, which means you're probably working in branches, and the point of the practice is when you merge stuff to the main line, then that's where you find the integration problems, not, as Neil was saying, at release time or build time. But it's a practice, and what you use is a software, a service, or some hardware or something that implements it. So technically, what you use is a CI server or CI service, but it's not the CI. When you say the CI, it's technically wrong, but we're going to be wrong the whole talk, and we're going to keep saying CI, meaning the service that you're using, not the practice itself. So why should you adopt CI? Well, first of all, you really want to rule out the human factor, because surely you might have set up static analysis, you have detect, you have KT-lint, you have Android-lint, you have tests, you have everything. But if you forget to run them, then they're good for nothing. Like, it's not useful if you have static analysis and you don't run it. So people will forget to run the checks, and you also don't want to have developers staring at the screen, you know, the famous XKCD compiling comic. You don't want that. You want people to be free to go on with other stuff and maybe go back and fix things if there's some problem. But you don't want to have staring them at the screen for like 15, 20 minutes, waiting for CI, for the static analysis and the tests and everything to run. You can, with a CI, you can decide whether you want to run tasks on demand or scheduled. So for example, you could have on demand could be, for example, when you push code or you open a PR or you update a PR, that's on demand. So basically when there's a need for it, then it runs. But you might also want to have something like scheduled tasks. For example, that might be built-in nightlies, or you might have a big integration suite of tests that takes hours to run. You don't want to run it during the day. You want to keep the devices free during the day and run it during the night. So it's basically, you can use sort of a cron tab and say, oh, run this at this time, run this at that time, and you can make the most of the 24 hours you've got in a day. Now, there's two main kinds of CI services, self-hosted and in cloud. Self-hosted are services, well, are software like Jenkins, like TeamCity. There's more of them, obviously, but these are the two main ones you're going to see as an Android developer. They're more enterprise-friendly and they're more customizable. Firstly, they're more customizable because they run on something you control the hardware of. So you have full control over what's running, where, how, when. And they are more enterprise friendly because some enterprise setups have the code base not being available from the internet. You might need like a VPN to get in and connect to the code base or something like that. That's a fairly common requirement. And the problem with cloud CIs is that they generally cannot access that code, because if it's not reachable from the internet, then it doesn't exist for them. But the downside is that they require setup, there's a lot of IT effort to go into planning a CI, setting up a CI, configuring it, and also maintaining it. It's really important, especially if your CI is connected to the internet. You definitely want to keep up with the software patches and security updates, because otherwise you're basically leaving everyone's free access to your source code, which is probably not what you want. On the other hand, in cloud services, there's a ton of them. Most famous are Travis, CircleCI, Bitrise, GitLab has its own CI. Recently, there's been introduced Google Cloud Build. There's a ton of others, AppVeyor, whatever. They're easier to adopt because there's very little you need to do to set them up, except specifying a configuration. And if you're an individual or a small company and you don't have the IT resources to set up and maintain a CI, then that might be an easy way to get in. Because there's very little to do. And also, because of what I mentioned earlier, they're not as enterprise friendly, and they can also be quite costly. So cloud solutions generally work billing you as a subscription or on the amount of time that you spend building things, so on the time or resources used. So that can build up over time, and with a self-hosted CI is not necessarily as bad because you might have to pay a high upfront cost for setup, but then maintenance might be part of a larger setup, so you don't really see that cost. But that said, there's still some that do kind of blur the lines that are available both as in cloud and on premises. For example, TeamCity, which JetBrains makes, buy TeamCity. Gonna pay my salary. But apart from that, if you don't have cash, don't worry. There's good ways to get up with a CI, get started, try out things. For example, most CI services, both in cloud and self-hosted, do offer a free tier. For example, open source projects on cloud services generally get a set of things for free. There's more than the normal free tier. But you might also get like a number of executors, and we'll see later what that is, for free. Or you might get a certain amount of CPU time for free every month, or you might have free unlimited usage for up to 5 users or 10 users or whatnot. So there's free tiers. You can try things out. You can see what works for you, and then you can commit financially to it later. That's easier to do with Cloud CI than with an on-premises one, obviously. So
yeah, so the anatomy of a CI. So again, CI is referring to CI server. We're keeping with that in here. CI is made up of nodes. There is a master node and agents and executors. So the master node generally won't be building anything. It's kind of the person who orchestrates, well, machine that orchestrates the jobs. So it'll delegate the work to all the different agents and executors. Quite often you'll have one master node with several executors and other nodes depending on how big your CI setup is, how necessary it is. The master node can be self-hosted or in the cloud. And then you have agents and executors, so they are basically the stupid node that obeys the master. They run the actual jobs. Yeah, the grunt. So they are the nodes that are running the jobs. It can be machines or containers. Most commonly Linux. There are Mac OS and Windows versions, so in the Android world, chances are you'll be using some sort of Linux machine. It's cheaper, it works quickly, configurable, so it kind of does everything we need it to do.
If you have an iOS part as well, you might want to have like macOS nodes, so you can have one setup for everyone, and Android works builds on Linux, and iOS builds on macOS. So
yeah. And apparently setting up a Windows agent is very simple as well. For whatever reason you do that, depending on your company's infrastructure. So yeah, in a CI, you have a build queue. So there'll be jobs which are given. They are in a queue, so like a serial queue, and they'll be executed in order. So one job is given, CI executes, runs this, delegated to some sort of agent node, it's build and run. That happens, you go to the next, that one's executed, to the next, executed, and so on. The idea being that stuff can push to the CI, the master node delegates where everything needs to go, and builds, and stuff is happening. So a typical job for a CI, app assemble, so that is actually building your app.
You want to make sure that your app builds.
Yeah, it's kind of the most important step for like starting out. Does your app compile, right? Running your tests, so you've written lots of tests, that's great. Running your static analysis, so in here we're using lint, detect, kt-lint. It's worth on noting that detect is not dependent on build flavor, but kt-lint is.
Depending on the Gradle plugin you use, but generally you don't care too much because kt-lint and detect are fairly quick because they don't depend on compilation, they just look at the code, and they're generally the fastest parts of the chain anyway.
So yeah, and that's...
Yeah, you generally just want to run this on a simple setup for the release only. You don't want to assemble debug on the CI. You don't particularly care. That's what you do all the time when you code. But in some cases, you might have a more complicated setup. For example, you might have a bunch of flavors, and then you need to do the same job for all of them. And that's pretty much converging to running the build task, which, as you might know, is the do-all Gradle task. It's going to do everything. It's going to build the app, regard the app. It's going to run static analysis. It's going to run tests. It's going to do everything. So.
And yeah, and that. Wait, is this not this one? Okay, yeah. So obviously, running build. That's going to take quite a long time. Maybe it's not.
You could do that, but.
Yeah,
not
like
the best way.
Yeah, using that setup is not the ideal situation, right? It's kind of doing everything. If it fails, something goes wrong, it's going to be kind of difficult to go through. You want to fail as early as you can to know where something's gone wrong. So a better job would be to kind of split out that build into all the different points of creating the release process. So you assemble the release, you assemble the test release, your connected Android tests, your lint release, running all of these things through. And it means the kind of breaking down that sequence is clearer for if something goes wrong or if it's going to fail at a certain point, and it just kind of allows you to control the process a bit more. But this still takes too long, right? This is all being done in a serial manner, which is not ideal. So in a CI, you can have multiple executors. So we want to be able to utilize that. So basically, our idea is to use threading to try and split our jobs and run the jobs that can be done in parallel. So that is achieved by a concept of pipelines. So a pipeline takes a group of jobs. A pipeline is a group of jobs that are executed in stages, and they can be parallelized. So this will take less time than running that monolithic build.
Doesn't necessarily, but could.
Yeah. The idea is we're trying to optimize this time because obviously building everything in one big sequence in the app takes potentially too long or an inconvenient amount of time, to put it politically. And pipelines are supported in pretty much any CI setup, self-hosted in cloud. Anything we've listed off has some variation of a pipeline. Other names for pipelines are workflows or build chains, just in case you've had references from somewhere else. So yeah, use pipelines. Pipelines are great. They're going to make things faster.
Good. So let's see an example of a pipeline. Thank you, Neil. For example, a simple pipeline could be something like you check out the code, then you warm up your build. For example, you spin up the Gradle daemon, you download dependencies, you get everything done that you need, and then the next step is running all the actual checks that are the meat of what the CI is supposed to do. For example, running the unit tests, for example, running the connected tests, for example, running the static analysis, building APKs, whatever you might need. It's very important to stress that depending on your setup, depending on your code base, depending on what tools you're using, this might not be the best solution for you. When I was playing around with stuff, I realized that changing things would counterintuitively make the build longer than I expected because of overheads, because of many different factors. So when you do set up your CI, we're going to show you a solution that we found that works for us, but you really want to go and play around with things and make sure that you end up in a situation where you are actually minimizing for the minimum build time, because obviously CI is asynchronous from development, but obviously you don't want to stare at GitHub and waiting to merge a pull request because CI is taking half an hour. So let's look at a case study. In this case, we're going to use CircleCI. Why CircleCI? A number of reasons. It's widely adopted in the community, so that's good. And anyway, most of the cloud CIs that you can use kind of work the same. They might have a slightly different configuration or different options, but just when you get to the core of it, that's pretty much always the same stuff. So you can take the same concepts and apply them to other services as well. And also, we have an example ready, which is good.
I should also add that for CircleCI, so I was used to using self-hosted Jenkins setup before, and the learning curve for CircleCI is really easy. It was less than a day to be able to set up some sort of configuration that does everything that we wanted to, which you'll see a lot of details about later. At first, it might appear like some of the syntax seems a bit complicated, but once it's broken down, it's actually really straightforward. To put it in context, I actually did the configuration for the iOS team as well in like one morning, learning about all of their CircleCI setup. So once you get the hang of this, it's super easy to deploy. So any new project you're starting, you've got no excuses not to use something like this.
So CircleCI, as most cloud CIs, it is Docker-based. That means that everything that you do is going to be running in a Docker container spun up somewhere. You don't really care where or how. You just care that that's how it works. It's configured with a YAML file, and we're going to see the details about that later. And this YAML file is versioned. Right now, the latest version, that is also the version that we're going to show in the example later, is 2.1. So we're going to go with that. And also, last thing, as I was saying, if you don't have money and you just wanted to play around, you can do that. There's a free tier, and that's another good thing about CircleCI. You can use CircleCI for any project you want, including private ones, for free. You will have one Linux executor for free, which is not much, I'm telling you. CI is going to be slow, but it's going to work. If you're working on something open source, that's even better, because then you get 4 Linux executors for free. And you can also get macOS ones, I think, maybe 2. I don't remember the details, but you have to specifically ask for them. So it's easier to play around if you're doing an Android CI setup, because obviously you're fine with Linux. In our example, we're going to be looking at the code for Squanchy. So Squanchy is the conference app that the conference app for this conference, I've said conference a bunch of times, is based on. It is a fork of it, actually, but I don't think there's much difference. I don't know, but probably. It's a free and open source conference app. It's written 100% in Kotlin, except for some code that is in Java that we have to copy paste because the author was too lazy to publish it somewhere as an artifact. So we have some adopted code in there, but that's all we can do. There's unit tests, but there's no instrumentation tests, mostly because it's a side project and we didn't really have time to set that up. That's a whole world of pain and complexity that we are not going to go into. That would be a talk in and by itself anyway. So we're just going to pretend that you're going to do it yourself, but we didn't. And we have static analysis. As we said, we have everything that we can use. Obviously, we use the Android Studio, we use IntelliJ to build it, so we have all the inspections and everything. But on the CI, we have everything that we can. Android lint, detect, and KT lint. The app is not very modular, but that doesn't really make that much of a difference when it comes to CI. In this case, there's one main app module and then another module with this copy-pasted code that we're going to get rid of at some point. Now, getting started. Before you start going crazy, going to town with setting up a CI, you need to make sure that you have your basics covered. So you need a working Gradle build, obviously, because if it doesn't build, there's no point in running a CI. You need to identify the tasks in your Gradle build that you need to execute, but not just that. You also need to identify the tasks that you need to execute that are not part of your Gradle build. We'll see that later. You also need to identify what secrets your app needs to build. For example, you might have place services. You need the JSON file. You do not want to commit the JSON file into the version control, especially if it's a public project. You definitely don't want to do that. And you don't want to have API keys, secrets, and all that stuff. You should instead use environment variables for that. So let's see. Working Gradle build. Does it build? Yes. Good. Next. Let's identify the tasks that we need to run. First of all, obviously, we need to check out the code from GitHub in our case. That's not Gradle. That's going to be done by the CI. And this is why I'm saying not all the things that are going to do are going to be run in Gradle, but it doesn't really make that much of a difference. We also need to warm up, as I mentioned earlier. You want to make sure that all the subsequent steps in your workflow are ready and take the least amount of time. You don't want to re-download dependencies every time. You don't want to recompile the app every time. Ideally, you want to do that, download stuff and compile stuff just once and be done with it. In our case, we have download dependencies, which is a task we created that is basically just depending on the dependencies task and Android dependencies tasks that are built into your build. Those will force Gradle to resolve the dependencies of your project and download everything. So that's going to be warming up the caches for you. And then the next step that we will need to do is run unit tests. In our case, just for the release build, for the release flavor, build type. I'll get there eventually. Static analysis, as we said, no surprises there. So cool, we're done. And the last thing is, what secrets do we need? In our case, in this app, you have Fabric, so you need the API key for Fabric. And we use Algolia, which is a cloud-based search indexing service. So the search is powered by a cloud service, and there's an API key for that, and there is secrets and stuff, configuration. And we also had some other things. For example, the application ID that is going to be used is configurable. It is not hard-coded because it's a conference app. You probably want to build it differently for different apps. But the same is going to be if you have multiple flavors of your app. That's something you want to do as well. And then we have the play services JSON as well, as I was mentioning. But the play services JSON does not work with environment variables. That's a problem, but we're going to solve it in another way. There's a pro tip here. If you do want to use, if you do want to use a CI, you will need to use environmental variables. And there's a plugin made by Novoda that is going to help you setting up things. It's basically providing you a very nice API to say, oh, I need this secret or this placeholder, and you're going to get the value from this file, and then you can have a chain of fallback saying, this file, if it's not there, try this one. If it's not there, try that other thing. And you can say, try a file, or try the environment variables. If it doesn't find it anywhere, it's going to fail, which is fine. It's good. It's what you want. It means you haven't set up things correctly. But it's very helpful because then you can take these secrets, put them in a file, not commit the file in VCS, actually ignore it. And then on the CI, you can provide environment variables to provide those values in a way that is not publicly available to everyone that is using the CI. Especially important for key store passwords, for API keys, all those things that you really don't want to provide to people. So we're all done. Next step, we need to configure CircleCI. CircleCI, again, YAML file. It's not that complicated, but it's going to be quite verbose. You have to put a file in the .circleci folder in the root of your repository. And the name is config.yml. Its version, as I said, current version is 2.1. So how does this file look like? It looks like this. There's a lot of stuff there. Don't worry. When you boil it down to the components, it's actually quite easy. There is a version, 2.1, as we said. And then you have executors. Executors are basically defining the machines or the containers that your code is going to be run on. In our case, we only have one, which is Android, because we are only running Android. We can say, this is the working directory. This is the Docker image or images to use when building, when spinning up the container. And then you can define environmental variables to provide all the secrets. In our case, we have a bunch of mock values that are just enough to make the build go. We don't build the APK at the end. We don't care there. We're doing it manually. So for us, that works fine.
I was also going to say that in the Docker image, CircleCI gives you a bunch of default Docker images for Android. So you just select one and roll with it. You don't need to bother about setting up your own Docker images.
Next, we have commands. Commands contains a list of commands. A command is basically a thing to do. And in itself, it can contain a number of steps. It contains actually a list of steps. So the general structure of a command is the name of the command, the list of steps. And each step has a specific name. There's a bunch of built-in steps, and you are going to use them. We're going to see a bunch of them now next. All the steps have a description, which is useful to set because it's what shows in the CircleCI web UI when you build something, so you know exactly what's going wrong. And they might be more descriptive than the actual step name, so it's much better for that. And then there's other configuration that depend on which kind of step you're running. For example, one you're going to see is save cache. The description says as well, it's basically saving the cache. You tell it, OK, take these paths on the file system and save them for later. This is really good because you can basically you can say, OK, download all the crazy Android SDK stuff that you need, and then I'm going to save them. So next time you don't need to go and download them. You can just get them from your internal network, which is going to be faster than re-downloading everything, theoretically anyway. It's very important to note that there is a version in my key name. So every cache file, every cache entry has a key. And you really want to have a version at the beginning of the key name, because if you need to invalidate the cache for any reason at some point, because you realize that you've done something wrong, then you want to be able to invalidate them by just changing the name. So a good way to do that is use the versioning. It's also immediately clear that you've changed something and why. The stuff in the double curly braces are placeholders. They're going to be replaced at runtime. In this case, I'm putting the checksum of a certain file. For example, you might have your cache depending on the dependencies list. So you might want to have the Gradle file where the dependencies are listed as part of the key. Because if you change dependencies, obviously the cache you have is not going to be fine anymore. You need to create a new one. And the same could go for the configuration script itself. Restore cache, obviously, other way around. Not much to say. Attach workspace is saying, OK, get my workspace, and we're going to see what it is in a second, and put it here. And the last one is run. It just runs a command. Very easy. We have a bunch of commands. You're going to see there's save, restore, save, restore, save, restore, and then a bunch of other things that are basically saying what I mentioned at some point. There's a restore workspace there you're going to see. We're going to get to that later. Next up is jobs. A job is a collection of steps. Now, a step can be defined in line with the same syntax as commands, or you can call commands. So commands are basically a way to reuse steps in multiple places. That's just a convenience that you have, and it's very nice and allows you to keep your job definition easy. We have 4 jobs: checkout, prepare for checks, static analysis, and tests. And lastly, you have workflows. Workflows, the definition of a workflow is what says what the CI is supposed to do. In this case, we have a version, again, it's 2. That's the current one. And then we have the list of jobs that this workflow includes. You might have multiple workflows that execute different jobs, or part of them, they might be overlapping or not. An important bit here is that by using the requires, you can say this step actually depends on that one. And you're basically defining how the CI is going to execute stuff, the order in which things need to be done, and basically defining the directed acyclic graph of the build, which might fan out, go back in, do random things, as long as it's directed and not cyclic. So let's quickly look at CI run. The first thing, as we said, is checkout. What does checkout do? It checks out the code. It also calls the setup Android SDK, making sure we have everything that we need to build. It creates a mock JSON. We have a very simple script that basically outputs a file that contains mock values for the JSON that GMS is going to use, the place services are going to use when building. So CI is happy, build works. You don't really care about that much. It's just easy. You can see it in the repository. And last thing we do is persist to workspace. Basically, we've done a bunch of work, and we're going to say, OK, what we have done, take it, keep it on the side, and you're going to use it in the next step. So basically, you can see is save, well, get stuff, do stuff, and then save stuff. Then we move to the next step, which is prepare for checks. Prepare for checks restores from the workspace. So what we just saved, this is running a different container. So if you didn't do this, the stuff you just did would be completely lost. You want to do stuff and carry it over throughout your build and build upon it to make the thing as incremental as possible. Then we restore caches. as we have seen. Those caches might come from a previous build. And then we download the dependencies. There's the warm-up thing that we were mentioning. We save the caches again because that way they will be available for the next build. And then we persist the workspace again. So next step is going to have all the stuff. Again, get stuff, do stuff, save stuff, save stuff. I really like saying that. And then static analysis and tests. We restore from workspace, as always. They're both of the jobs are the same, so I'm just going to go through once. You restore from workspace, restore your caches, run the tasks, and then store the artifacts, the JUnit test results, the static analysis, HTML reports, and all that stuff. Again, restore, do stuff, save. So yeah, the TLDR of all this old section is this. All your jobs are going to be getting stuff, doing stuff, and saving stuff. All yours.
Easy. Yeah, so that is everything you need to know about kind of maintaining code quality, how to run CI, static analysis. So static analysis is good. You should use it. There is no excuse not to have at least some baseline of quality and consistency across your team. CI is good. You use a CI. The setup is really straightforward. We didn't even mention that in CircleCI, they provide you with a default configuration. So I think in like about 3-4 lines of changes, you can have a CI build up and running on CircleCI on a free tier. So it's really, really quick to get that reward of running it. And then running a static CI with static analysis is even better. And check out Squanchy. So I didn't contribute to it directly. I know Seb does a lot of work on it. But
some other people here as well.
Yeah, there's more open source contributors in the audience. It's a really good way to just kind of see like a slightly more advanced CircleCI setup. It's really straightforward, really well documented. Like it's worthwhile taking a look at. And just the project in general is really good. And yeah, that is everything.
Thank you very much.